ഞാൻ വിചാരിച്ച ഇത് ഇത്രയും തിരിക്കണമെങ്കിൽ സ്ഥലം വേണം. അപ്പൊ ഇതിനെ പറഞ്ഞിട്ട് ഇത് അത്ര ഇത്ര നീക്കി വെച്ചിട്ടാണ് ഇത്രയും തിരിച്ചത്. സ്ഥലം ഇല്ലായിരുന്നു. ഒരുപാട് മഴയും ദിവസം ഉണങ്ങുന്നില്ല.
All right, so good morning, everybody. Can you hear me well?
Yes, sir. Yes, sir.
All right. So, how was the exam? How's the paper? Nobody want to answer the paper?
Sir, it was good for me. I gave cloud computing and big data system.
Okay. What about others?
It was okay for me as well, sir.
Was it okay? Was it hard? Was it easy? Was it contextual? Was it too much?
Contextual, not easy, but contextual and interesting as well.
Good. Okay, guys, then thank you. So let's get going. So in the last a couple of lectures, guys. We did a lot of hands-on, and I believe that you guys must be enjoying also the hands-on of. We learned about a lot of the Dockers. We learned a lot about Kubernetes. Then in the last 4 lectures, rather, we saw the lecture that we saw the demo basically at our local machine. I mean to say with your local laptop for both Docker and the Kubernetes. Then we proceeded ahead to check for the demo at Azure Cloud. And as I mentioned, that Azure Cloud, you guys can create your free accounts yourselves with your personal accounts, and you would get some free credits also for you people to try out. Okay. So that's what we learned so far. Now today we are going to begin on the infrastructures as a service today. Okay, although we have seen it, but we will discuss the fundamentals from it, and then we'll go to PaaS and then SaaS. Okay. All right. So guys, the whole cloud experience started with the offering of infrastructure as a service. Now that's the reason I thought I should bring back this particular definition of the cloud computing once again, where the keywords like on demand, pay as you go are very, very important. Now what I end up paying is only for the time for which I have actually used the resources. For certain services, it might be the time based, or it might be some services, or for some certain services might be access based. That is how many number of accesses has happens over a particular period of the time. Or there could be some other services which are charged based upon the bandwidth consumed. So that's the reason that I brought back this definition of the cloud computing again to showcase this. Now, we shall be targeting the infrastructure as a service in the today's class. Now, general aspects about the IaaS as well as the specifics of the IaaS would be discussed. If I consider cloud computing, what is that it helps me to do? What is that it helps me to basically not to think in the terms of the hardware, but rather think about it as a software. Okay, what is that it helps me to basically look for the perspective change. That's where this particular diagram depicts the picture. Don't think it as a hardware angle. For example, how many servers are there, how many racks are there. No, what it says is that don't bother about that at all. Rather, think in the terms of how can you use those hardware as a software. Okay, that is what the thing here is. Now, guys, this is a traditional computing model where things are perceived hardware as such. Okay, if infrastructure is seen as this hardware, but it is seen like we still have to concentrate on so many things. For example, what kind of staffing would be needed? What kind of IT personnel would be required? How do I make sure to establish the security of the data center which I am establishing? What is the capital expenditure required in order to set up this data center? How should I plan for capacity? When I say plan for capacity, I have an application for which the number of users are growing. How should I basically maintain it? At some point in the time, I can also see that there might be some dip in the usage of the resources. How do I plan out for all those things? Okay. Adding to all those, getting the approval from the organizations is yet another challenge if it is a bureaucratic process of approval. Procurement process itself is a very tedious job. We have to raise the hardware request and then it has to go through multiple hands to get the signatures and approvals. This procurement cycle at times becomes very, very huge. That is all that we have seen from our previous discussions also. right? Now you can, guys, you can see the presentation, right?
Yes.
Yes, sir. Yes, sir.
Now, guys, you can yourself compare the difference in the time that it takes in order to start a virtual machine versus the time that it takes to procure a hardware machine itself. Apart from that, we also need to keep planning for the provisions, right? So we saw in the demos, right, how easy it is to configure a virtual machine, how easy to configure a Kubernetes code on the cloud, right? And ultimately, what you need a node, you need a hardware, you need a server, right? And if that is not available in the physical format, you can easily get it into the cloud, right? Apart from that, we also need to keep planning for the provisionings. For example, making the capacity planning in order to provision based on some theoretical guessing, right? Theoretical guessing means, say, for example, on Saturday and Sunday, the traffic would be higher, right? This is my understanding, based upon the previous experience, that the traffic goes higher by so and so amount on so and so days or so and so duration. For that, I need to have the extra servers in the place. So I also need to set up the load balancer for these additional servers, right? On the Friday, I set up the additional servers, do so and so work. All of these were the pains of the traditional computing model, where I see infrastructure as a hardware. Okay. I hope all of you would agree to me on this particular picture. Now, moving to absolutely new perspective of the cloud computing, there it is asking me to consider the whole infrastructure as a software. So here, what we are trying to understand? What we are trying to understand is that when the infrastructure becomes software solutions, then it becomes quite flexible for me. What do you mean by the flexible for me? So, for example, if I have to select the cloud server, so I can do so in a way that best matches my requirements. I can take care of the scaling up on demand, the termination of this machine, etc. Right? Everything can be taken care with the help of the code. When I say code, obviously I mean the software solution. And at the same very time, I also don't need to bother about hosting, machine type, etc. They don't have to bother about the procurement. They don't have to bother about the maintenance. They don't have to bother about capacity planning of the servers. Wherever the scale is needed, what is that they need to focus? Is on the important tasks that they need to develop the code, how their code is going to be scaled and efficient. This is something that developers would have to concentrate on rather than anything else. So these software solutions can always help my infrastructure to grow with demand and shrink with less demand as well. This is all possible through the hardware software solutions, not through hardware solutions. Okay. Theoretically, whatever capacity planning that we had to do is now no more required. Why? Because we have the scalability concept available. Of course, some sort of planning is definitely needed, but you don't need to really bother about the planning towards the procurement, maintenance, having people, configuring, etc. All those things can be avoided with the software solutions, right? Now moving on. So this diagram, guys, we have already seen in our previous lectures a lot. What is the intention of this diagram? To help you to identify, when we are talking about the infrastructure as a service, what are the things which are maintained by the cloud provider, and what are those things which are being maintained by the application developer, which is like us, the developers. There's an orange blue representation here. All the orange representation indicates that it would be our own responsibility, whereas the blue representation indicates that it would be the cloud provider responsibility. That's the only condition that I have brought in here in this particular slide. As you can see that there's a very clear demarcation when it comes to infrastructure as a service, where up till the virtualization layer, virtual machine monitor, it is all with the cloud provider. The cloud provider basically abstracts all the servers underneath and helps to create our own infrastructure using the hardware resources which are underneath. So what else you have to do? You have to create a machine at the click of your button, install the operating system, middleware, binaries, configurations, etc. Everything is something that you have to take care of. What kind of database is to be installed? This is also something that you have to take care of. What kind of patching is to be done? Everything is your own headache. Okay. That is what also which is being shown over here as well. As we move from infrastructure as a service towards the software as a service, of course, via the platform as a service. In case of the SaaS, in case of the infrastructure as a service, we have more control over the resources. Basically, in the previous slide, I projected infrastructure as a service in a little negative with respect to the headache. But when it comes to the infrastructure as a service, rather we have very absolute more control with you over your own application. You have more control over the virtual resources which you are hosting. You have more control over the security that you need to provide for this set of the services which you are hosting. As we move from infrastructure as a service towards software as a service, we lose that control, right? SaaS basically says software as a service. Look the example of the Gmail. There's absolutely no control, right? No configuration is required. No mailbox setting has to be done. Absolutely no headache as a customer to me. Where the data is being stored, whatever the type of the data I may be storing, like private data, confidential data. I mean, what I just know is there is some sort of privacy being maintained and the data is being stored somewhere. There is some secrecy which is being maintained. The encryption is happening and my data is safe. This is the belief that we have to keep. And with the same belief, there are thousands and hundreds of the organizations which have gone to make use of this Gmail service, isn't it? That is the software as a service. Now, what it has done, you just have to have an account and make use of it. That's all. Now, so quickly, if I can have a look at the infrastructure as a service. So there are four phases in which basically comes to the mind immediately. The number one is the cloud bursting. Second one is the multi-tenancy. The third one is the resource pooling. And the final one is a hypervisor, which enables all of these things. Okay. Now let me cover one by one. So guys, what is cloud bursting? Here we are talking about, before getting onto the cloud, we have our own application on premises and it is running pretty smooth. But there are days when the load on these servers increases, where we approach the cloud to take up this extra load. What is happening? Certain tasks which needs to be executed on the premises because of the overload, now these tasks are offloaded to the cloud so that these tasks can be executed over there. Additionally, the benefit is that there is no downtime at all. Basically, I'm running on premises. As and when required, I offload the task to the cloud so that it gets executed and there is no interruption of the services. Okay. So what is the cloud provider? What is the cloud provider provides? It provides the computing resources as and when required, as and when needed. And as you know, the features of the cloud, so there is no harm in going to the cloud. But most of the computation is happening on premises itself. So this is the concept which is called as cloud bursting. This maybe let me stay here. The second one is the multi-tenant computing. So as you can see in the particular diagram, each of the organization have got their own data centers. They have got their own databases and code bases running on their own set of servers. Okay, because the why? Because that isolation is needed. The partition was required. So now with the cloud, I can bring the logical isolation in the application. I can bring in the isolation with respect to the databases. I can run a single instance of my application. Classic example being of Gmail. Yes, it involves the application. It do involves the database as well somewhere. We do not know. So I can run a single instance of my application. Classic example, when each one of you use, right? Basically, the Gmail is providing the software as a service in a cost-effective manner because of the resources which are being shared over there. When I say shared, that does not mean that it harms. They're taking care of the data privacy, authentication, data secrecy, authorization, various levels of authorization rather. Whatever is required is being taken care by the Gmail team, and that's how it is being made as a highly usable. Third one is resource pooling. It talks about the management layer which pools all the resources underneath. So you may have hundreds and thousands of servers, right? All of them would be abstracted using this layer of hypervisor. It kind of gives me feeling that I have a single unit which has thousands of cores of the CPU and hundreds of the thousands of the GBs of the RAM. Okay, that's what I see. The last one is hypervisor. Hypervisor helps us with this particular abstraction. It helps us to provide the management layer. It helps us to create the virtual resources above the hardware resources. Now, there are two prime facets which makes infrastructure as a service special. Number one is elasticity. Another one is a virtualization, right? In fact, virtualization is the one which enables elasticity. There's expanding and contracting the resources as smooth as possible. Somewhere or some another, earlier also it was happening, but mostly it was manual in the nature. Let's try to understand this diagram as it is quite interesting in the nature. So earlier, how the planning was happening. With respect to the blue line, there was a predicted demand and you projected extra. Pay attention to the dotted blue line, okay? As you can see that when the demand is near to the projected, you increase the projection. Basically, what you're doing is a very scale-up approach. Then again, you see the projected and the actual demands are meeting at some point in the time. Then you again increase the projection and so on. In this approach, what is happening is that there is a lot of time when the resources are not in actual use. Similarly, it is same here at a multiple point in the times. Also, at intersection points, the application might be suffering from less resources. Why is this inefficiency happening? Because I do not have the flexibility to scale up or scale down as per my demands. And that is what is being provided by the virtualization, the containers, the VMs, that is being termed as elasticity. I'm sure all of you understand the elasticity. As I put pressure, it expands. As I release, it contracts. Isn't it? That's what is expected here as well. Meaning, there are full of two lines. That is a green one and the red one line. The red one is actual demand, and the green line is automated elasticity with respect to the demand. Green line can very easily go one step ahead of the actual demand. So whenever there is no demand, it dips, and whenever there is high demand, it scales up. Now, when you consider this with the one which was used traditionally, a huge amount of costing was spent on capacity planning implementation, which is now nullified because of these two aspects of the cloud computing. Okay. Any doubts, any questions so far? All right. So if there is no doubt, then let's proceed further. So what is the value which infrastructure as a service brings to the services? We have seen from the previous diagram that how the elasticity is helping. That itself is very cost effective in the nature, right? The concept of the cloud bursting, basically we are trying to take the load from on-premises servers, and whenever it is not possible, we offload it to the cloud. Okay. So here what I'm doing is that I build my resources in such a manner that it provides me the security. It provides whatever infrastructure is required for whatever needs. Beyond that, it is also possible because of the cloud bursting. So here I'm trying to build an environment rather, which not only uses the local resources, but also can reallocate the process to the infrastructure as a service cloud. Okay. Now, please note here that the organizations on the fly cannot take the decisions. They need to look into the various considerations, because what is happening now is that you're offloading your tasks so that basically there shall be many challenges that you would have to face in this case, because you're offloading your own tasks. So let's talk about what are those challenges. What are the considerations that you have to think of? Number one is, earlier you were writing the code to your own infrastructure. Now you shall be writing the code in the cloud provider's infrastructure as well. But you would be entering into the vendor lock-in now. That's a problem. If you're writing the code for one specific type of hardware, that is something which has happened with the most, Microsoft Azure. Okay. But later on, they also provided support for the Linux. In fact, Linux subsystems is also something that they provide in the Windows machine now. That's a kind of flexibility which is being provided by the Microsoft. So vendor lock-in is a problem. You don't want to enter into it. Okay. And hypervisor, which we are talking about, basically the one which helps us to manage the offloading of the tasks. Basically, the interface gives me a feeling that all the resources which I have, either on premises or on cloud, are same for me. Okay. That does not come cheap. If you take VMware, it doesn't come free or easy. Okay. It is pretty significant in the nature. The software itself is pretty significant. You need to look into these details to take a decision if whether you really want to go in there. Okay. The next one is, we are looking here to send the application process to the cloud because of the cloud bursting. Now, where will the data get stored? How would the authentication take place? How would we maintain the various identities of the various people? If it is financial information or if it is banking information, where is that it is put, because of all those financial institutions or healthcare institutions are all governed by the the various compliances and the policies. They all are protected by the different policies created by the different government agencies. Okay. So how would your cloud vendor be able to basically be compliant of all of these standards and policies? That is something that you need to understand. At the same time, you also need to see that how the day-to-day operation shall be run. Of course, in order to maintain the business. So these are the various considerations. Even now, when someone is thinking to migrate to the cloud, they look into the various of those considerations as such. These are generally top 4 considerations that I just explained, and there can be many more that you guys can think of. All right. So now, guys, this is a very important slide that is there in the front of you for all of you as engineers, architects, and the leaders of your own companies. If you have to decide how, whether to go for IaaS or any other type of service, this below decision tree would help you to take the decision as such. Okay. Please pay attention and focus your attention on the slide. Is very, very important. The question number one, which is asked usually, is that do you need a full control at all costs? In order to answer this, we need to answer to the fact that whether do you have an IT staff which is well versed to use the cloud resources, how to handle and maintain it. Do you have that kind of personals, the resource personals and flexibility to handle that? Of course, if yes, then infrastructure as a service is an option for you. Otherwise, no, and then you explore the other solutions. Is vendor lock-in a problem for you? If yes, then infrastructure as a service is an option for us. If vendor lock-in is not a problem, then we look for other types of options. Do you know your transaction volume? Transaction basically means the financial transactions related to the banking accounts. For example, sending money from one bank account to another. If you already know about that volume, then you can go for platform as a service. If you don't know that volume beforehand, then infrastructure as a service is the right option for you as you have some control with you. That's the preliminary of infrastructure as a service. Okay. Now we are slightly moving towards the infrastructure as a service provided by the cloud. Now I'm sure you don't have the questions like why AWS and not anything else, or why Azure and not anything else. See, we had to lock in some vendor, either this or that. We had been working with the AWS team for quite some time, and that's where we have locked in the AWS as our practice playground. It doesn't mean that you should not explore the other cloud service provider options, because on a higher level, if you compare all the types of platforms, almost every platform provides you all types of options. The way of deploying the applications might be different and concerning, but pretty much majority of the services exist in all the platforms. For example, you want the container services, then it is there with all major leading providers. You want to run your web application to run on a serverless code, then yeah, you do have the functions in the Google or in Lambda or in AWS, etc. Likewise, you want DNS service, that is there pretty much in all of these three providers. You want compute service, it is there. Names might differ and the way you provision might differ, but otherwise the service wise it is still the same concept. So slightly we are getting into the AWS specific details now. What is a web service? I'm sure all of you would have some exposure and know about web services. Web service is basically a piece of software which is there. Now when I say is this there, it could be on the server which is hosted on your home, or it could be the part of your on-premise data center. Or it could be the part of your some data center that you have hosted for some purpose or some research labs. So web services can make itself available over the internet. So what is that you can do with this web service? Basically, you have to make a request, and what it will do is it will formulate a response and sends it back. Okay. Of course, you need to know a few things such as like what is the name of the web service, how are you going to target it. Certain details are required, but leaving it aside, I can make an API call to it with the request, and it is going to give me a response back. Now, this is possible in the two different formats, XML or JSON. A client makes a request using the internet, it goes to web service. Web service which is hosted, and from there you get a response. Similar thing is what we need to look in for even when it comes to AWS. So when I make a request of what, for example, creating an infrastructure in the sense that creating a virtual machine or creating a storage request, this is all the software request which is going in. Okay, this is the API call which is going in here in this case as well. Basically, I'm targeting an endpoint using the API. Okay. And when I target that, it is basically going to get the things done and provide me the access to it. Okay. So this is what it happens. And that's why I would want to bring in the focus from the slide number 1 again. Now I'm seeing the whole infrastructure as a software solution and not as a hardware. So what is the AWS cloud provides to us? Number 1 is secured cloud platform. What does the platform offers to us? A broad set of cloud services. You name it, and you most probably it would be there would exist a service or a offering for the same. You talk about DNS, it is there. You talk about creating a private network, it is there. You talk about creating the virtual machine, it is there. The list is endless. As I understand, there are close to 100 services offered by AWS. Please note that I'm not advocating for the AWS by quoting the number is greater or no. Absolutely no. I'm saying that many relevant services are provided in each category by AWS, and all of them are highly secured, reliable, and they're all present in the scalable infrastructure. So here it provides less administration. There is no setup cost. It means that there is no capital expenditure which is required. What is required is operational expenditure. Basically, it tells us whatever you use, you pay for that. Obviously, it provides us more flexibility than our own infrastructure, which may be present either on premises or data center facility. So it has given me these services. Now, what do I do with these services? I use these services as building blocks in order to deploy my application or host my application. Okay. If I can bring in the comparison with my traditional IT infrastructure to the AWS, then AWS do have the security groups. It does have access controls also. AWS does have the infrastructure as the IAM. There are various services which basically match the firewall, ACLs, and administrators in the IT space. When it comes to the networking, we can create our own virtual private cloud or do the load balancing related to the router setup that we may have, the network pipeline that we may have, or the switches that we may have in the IT setup. Okay. Compute, I have the image using which I can launch the EC2 instance, whereas on the on premises, I have the host machine, which we have their own operating system where I can run my application. When it comes to storage, we have the elastic block storage in the AWS, which provides the block storage capability. File storage capability by EFS. Okay, S3 is the object storage capability. Database storage happens through the RDS. Similarly, I used to have RDS server, network attached storage, which makes use of Ethernet in order to provide the storage using the network file system. Or I used to have the SAN, which either worked on the Ethernet or huge fiber net, which used to give high performance. Okay. Or there was a direct attached storage to the nodes as well. Now, if you bring in the equivalence, there are a lot of similarities what's present in the traditional IT and what's present in the AWS. Probably this is not a very full-fledged picture, my dear students. It will definitely help you to but start and think in the direction to consider that what all things that you may need are already present. So these are the various categories of the services which are present over there in the AWS platform. You talk about analytics, you talk about media services, you talk about machine learning, compute, you talk about network support, you talk about IoT, etc. Okay, basically it has one or other service which you may need for any other purpose. And to mind you, this is not the services actually. Rather, these are the categories of the AWS services. Under each of these categories, you would have a line of AWS service, which we are going to see in a while. They have support for the 5G. 5G basically talks about minimizing the latencies. So basically, they have the services which you can cater to support that. They have support for robotics. They have support for maintaining the sign-ons for the users. I mean, they have pretty much every bit of the service for which every bit of the requirement related to the application development or deployment. Choosing what service is required depends upon the business goals of your applications and your app organizations and the technology that is required behind it. So this is some example, basically sample that's shown over you here in the left-hand side of the screen as you can focus. So we can have users who are able to access the AWS. You can see over here using the networking, the developers can create virtual private clouds, which hosts a service of compute, service of database, and a service of storage. Okay, in storage, we have S3, which provides object storage. DynamoDB basically is a NoSQL database, which represents the database. Next is the EC2. EC2 is basically the compute. So here, probably the users are storing some information in the sense that, for example, if I can consider the application of Facebook, what does the Facebook have? It has a lot of messages, a lot of media. Whatever the messages are there, they are getting stored in the DynamoDB in the NoSQL form of the key value pairs. Whatever in the objects like picture, media, sound, multimedia, they are being uploaded. They are still being stored in the S3. In fact, you can create an index of whatever is getting stored in the S3 and place it in the DynamoDB. Thus, you can say the services that you choose should help you to solve your business goals. Okay. Likewise, guys, there is yet another example being shown over here in the screens on your right hand side. It integrates the edge computing platform IoT Greengrass within a Homes interface. Basically, this is a part of the Raspberry Pi. This is for the face recognition of the person who comes in. The initiation happens to the user who provides the voice control through the Echo Dot or Echo Alexa, etc., from where it sends the request to Alexa. Then there is a Lambda function which does the face recognition, which in turn uses the data which is present in the S3. So what I'm trying to say, depending upon the need of your solution, your requirement, those respective services needs to be picked up. Okay. In the below portion, I do have an example from the Google Cloud as well. So you have your Google IoT Core as a service offering in the Google. There is a PubSub over here. In the AWS, we have the broker for IoT. Then we have the cloud functions, whereas in the AWS, we have the Lambda. In GCS, we have storage, which is Firebase storage, whereas in AWS, we have S3 for the storage of resources. Here we have the Raspberry Pi MDNS running over here, whereas in the AWS, you have AWS Greengrass running. So pretty much all of the services are there in all of these three cloud providers. Of course, there are other cloud providers as well. For example, Oracle is there, and mostly it is business to business. We also have IBM, but these are the major ones. AWS started the offering with most of its services as IaaS. Azure started the offering most of its services platform as a service, and later it come down to infrastructure as a service. Google started the offering most of the services as software as a service like G Suite. Compared to the SaaS offering from the Azure, and AWS is pretty less compared to the Google. Moving on, let's try to understand the ways with which we can interact with AWS. What are the ways through which we can use these services? There are three possibilities, and all of these three options are being built on the top of the REST APIs. Either you send a trigger through GUI or through CLI or through some other SDK using the endpoint as such. It all calls the same API in order to get the job done. Now, the first way is using the cool looking AWS GUI. So here, first of all, you would get authenticated with your user login and password. This is what we demonstrated in the previous example as well. Secondly, using the CLI, you need to give the access control and the access ID through which you shall be identified or authenticated, and post that you shall be able to use the services which are assigned to that particular user. Similarly, the same can happen using the SDKs, because applications making use of these SDKs. So whenever the code that you have written may be in any language, for example, like in Perl, Python, Java, then using the SDK, you can get the job done and your application can get authenticated. Once your application gets authenticated, then it can target to use the same identity and management service for authentication and proceed further. Okay. Is there any doubt? Is there any question? Are you able to understand, guys, what I'm talking? Can I get some few yes, no in the chat window? So far, are you following me? Okay, what about others? All right. So cool, guys. Then if, let's just proceed further. So guys, now the big thing to understand while we are moving to the cloud is what are the things that we need to keep in the mind. Okay. So guys, I'm covering it from the AWS perspective, and feel free to ask me any questions you may have for any other context also. But I wanted to tell you that there is a framework which helps us to adopt to this new migration. That is migrating to the cloud from on-premises or set of services that I have. So this framework is called the Cloud Adoption Framework. This framework provides the guidance around the best practices to the organizations. So it shall help towards the IT life cycle and helps us to quickly adopt the cloud. This cloud adoption framework is organized into 6 different focus areas, basically targeting to business, people, and policies. So these are the 3 important things which it targets. Okay. Those 6 perspectives are nothing but the technological and business capabilities of the organization. And these perspectives consist of the set of capabilities with respect to each one of the focus area. With this, what an organization can do is they can identify the gaps with respect to the skills of IT personnel who are there and the process which are actually involved. It can accelerate the migration from your own premises to the cloud. So if we look at the business, what is that it looks at the business? It basically talks about the alignment of the IT with the business perspectives, whether it is aligned or not aligned. When it comes to the people, prioritize the training of the staff. The organization changes which are required actually in order to bring in the agility, because the cloud is all about agility. Because the agility basically means that things are moving very, very fast. People mindset should change towards this. There should be adequate trainings which should happen around the same. You need to bring in the good staff which can take care of these things. Fine. Next, coming to the governance, here we have talked about the businesses and the people. Now, this governance should basically bring the skills and processes which should be aligned with various IT strategies and goals with which the organizations actually work. Coming to the technological capabilities, first we talked about the platform. What is the nature of IT systems which are there? What is the architecture of target state environment? Security requirements should be met. Operational wise, we have to define the day-to-day, month-to-month, year-to-year operations which shall be required in the cloud environment. So basically, this particular framework provides us with insights on all of these capabilities. So you can have a look at this. This is a global infrastructure. You can see here there are various continents. Over here, you can see here there is 99 more than 100 availability zones which are present in more than 32 launched regions. In India, they started with Hyderabad also as one of the regions. Earlier, they had Mumbai region and with 2 availability zones. Likewise, there are some in the China as well, but there are things which we need to understand for the China region separately. So if you see, all of these regions are strategically placed, which caters to the various whole of the world. Not only this, you can also view the details of the regions and their corresponding availability zones as well. Although, now proceeding on guys, some of you may already be the experts of the regions and the zones and the cloud itself also, but in interest of all the people, now let us see what is all a region is and what a zone is. A region is basically a geographical area, and what happens here is that these regions are all isolated with each other because they are all designed to tolerate for failure and provide the stability. What we need to understand is that when it comes to the regions, the resources in one region are not automatically replicated in another regions. That replication can happen within the availability zones of that particular region, but that not between the different regions as such. If you want to bring in the cross-region replication, then it is on your own responsibility. That is the end user's responsibility to do the data replication across various regions. Of course, there is a connectivity between the regions as well. There is a network infrastructure which acts as the AWS backbone, which connects all the regions. Okay. Apart from that, each region, they provide full redundancy as well as connectivity to the network. Another thing that we have to understand is that each of these regions internally have availability zones, and these availability zones are built in such a way that these are at least 100 kilometers apart from each other. Why is it so? Because it helps in duplicating the data, as well as you need to reduce the latency as well as by bringing to the proximity of the user. If at all there is some loss in some availability zone, then other availability zone in that region can participate in serving the data. Another thing that we have to understand is that new regions, when they are built, they all are disabled by default now. If you want to enable them, you would have to explicitly go to your account and enable them for your use. But all the regions, I think, created before March 2019, they are all default available. All right. So how do you select a region? Now the question is, if you want to launch your application, first thing that you need to do is you need to select a region. The first thing that you should check is that whether the services you need are available in that particular region or not. Not all the regions have all the services. For example, GPU-based virtual machines are something which are not available in all the regions. So it depends upon the type of the service which is being offered, the kind of resource which is available in all those regions. Of course, what they do is once they launch the region, not all the services can be expected in it, thus they upgrade the region gradually. So you must look for the services which are available. and which are not available in that particular region. For you to really go ahead to make a selection, then what are the legal policies that I need to adhere to? Are there any local laws? Are there any data protection laws mandated by the local governments? There are certain things which I need to look up to. Now, in our country, India also, our government has made the policy that whatever data is being generated in India should reside in India only. Because they need to run the certain things like judiciary to take some decisions. If every data is being there in the US itself, then judiciary has to be referred to the US itself. Next one is the distance. It defines the latency. Just because some services are being offered at the low cost, I cannot put that service somewhere around in any part of the world and expect my application to serve all those purposes. It would certainly have the latency. So it is better, especially for the Indian users, it is better to launch the machines in the Mumbai or Hyderabad region servers. Why? Because it also helps to reduce the latency. The final one is the cost, because the cost may vary from region to region, my dear friends. A simple example. For example, I remember the US East one is the original and the earliest region. There, the costing of the T3 or any other kind of machine you take is lower as compared to any other, as compared to the cost of a virtual machine hosting in a new region. And it is a considerable difference of maybe 1.5 to 2x. So I have basically tried to, what I'm basically trying to do is I'm trying to tell you that you need to look into the cost difference as well, because if the application runs for only a couple of hours, it does not matter. But if the applications runs for every day, 365 days and 24 crores by 7, then of course you must look into the cost consideration as well. Okay, so the over point is the small difference over here in the cost would result in a huge difference when you run the machine for 365 days, 12 months, 24 crores by 7. That itself becomes a huge amount. Let us now move to the availability zones. AZs are out there to provide the high availability. That's why they are also called as availability zones. Guys, understand this concept is very, very important. This is very, very fundamental concepts going on right now. For some of the people who are new to the ecosystem, this is very important. So if you get any questions, any doubts, please don't hesitate to stop me. So these availability zones are built in to make sure that it provides availability to the applications in a very resilient manner, and that it has capability basically. So availability zones provides us a resiliency so that we have the capability to recover from any tragedies which could happen in any of the availability zones. So as you can see here in the diagram, there is a region which is being defined, and each region you would have multiple availability zones. These availability zones are being defined over here for the fault isolation. What does it mean? It means if something bad happens in one availability zone, then that shall not affect the other availability zone. That's the reason there is a distance being maintained, good enough distance being maintained, but it is also not that too far away. And obviously these are all connected to using the high-speed network on an optical fibers. Each of this availability zone does have a multiple data centers within it. Okay. Now let's talk about a data center. These data centers are the foundations for any cloud service provider company. These data centers have utmost secrecy, and the exact location is something which is never revealed as such. They are built with a lot of redundancy, power, network, connectivity. All of them have a good amount of redundancy. So the data resides in these data centers. The data gets processed into these data centers. And typically in each data center, we have somewhere close to millions of machines, millions of physical servers, which basically have a redundant design. It anticipates the problems and it is built to tolerate the failures. At all levels, it has to ensure the service availability to the end users. Now, AWS infrastructure features three things importantly: elasticity, scalability, fault tolerance, and high availability. So these are the three main pillars of the AWS, or maybe any cloud as such that you want to take. Now let us briefly discuss about the compute category provided by the AWS. It has multiple services. I'll tell you the purpose of each one of this. EC2 is basically provides a virtual computing machines. It also has the provisions for auto scaling using the AWS auto scaling groups. It also supports container services. Container support the Docker over here. It also supports the container registry, where if you have to maintain your own registry in order to have the custom images. So use a particular image and create a customized image out of it. And you don't want it to store this custom image in the Docker hub, but in your own registry. That's where the EC2 container registry comes into the picture. Then you have Beanstalk. It basically helps us with launching the web applications and helps us to scale on certain default web servers like Apache IIS. Lambda provides you serverless computing. Here you just have to take care of the code and not run the code. Only when the code is running, then only it is charged. Otherwise, it is not charged, and even you don't have to bother about the infrastructure at all here. That is the reason it is named as serverless computing. Basically, it is just a function. Whatever you have written, you would just run. Where it is running, how is it scaled, everything is being taken care and being maintained and managed by the cloud providers. Okay. Another service which is there is a Kubernetes service. All of these details about the Kubernetes are present in the EKS as well. There's also another one as well, AWS Fargate, which basically is a compute engine for ECS to run container services, and there are no need to manage these servers basically. I'll take a quick pause to check if you have any questions or doubts.
Sir, this Fargate, can you one more time explain? AWS
Sure.
Fargate.
Sure. So you saw the demo, right? Basically, when I was explaining in our Azure, we saw the demo of AKS, correct? That was something, the containers
Yes.
that we had,
Okay.
correct? Now, please try to understand, when we talk about Fargate, we are basically not worried about the servers itself. Okay. So Fargate basically becomes a serverless mechanism for the hosting the containers. You don't manage your servers, you don't manage your nodes or your clusters. You only define containers and resources. And AWS will provision it for you by the own. If you remember, in the AKS, we manage the control plane also. We manage the masters also. We manage our worker nodes also. Yeah. We basically defined scaling, we defined networking, we defined our own node pool. That is the most important thing. So that is the difference between how the containers are run over Fargate versus the containers are run on AKS or ECS, whatever like you want to say, AKS or Azure Kubernetes services, or maybe Azure Elastic Container Services. Excuse me. Is it clear or not?
Yes, yes.
Sir, I do have one question here. Like Fargate is because AWS Fargate is abstracting few things, like it's managing the servers, and is it going to be more in the terms of cost? It's more costly than the ECS or EKS?
Very good thought process. So see, when we talk about the costing, it depends upon when you when you run the containers, right? So you basically you yourself would have to choose a launch type in the AWS. Do you want to run ECS on the EC2, or do you want to run ECS on the Fargate? When you run ECS on the EC2, you do not provision any EC2 instances of the virtual machines as a cluster. Whereas when you do ECS on Fargate, you do not provision EC2s. And AWS will provision the compute per task. Here, in the case of when you run ECS on EC2, you basically pay for EC2 virtual machines. That is the costing of the virtual machine on demand, spot or reserve, whatever you have taken, whatever type of the virtual machine you have taken, you would be paying for that. Whereas with regards to the ECS on the Fargate, you pay per vCPU per second and per GB RAM per second allocated to the tasks. So I repeat again, while you have to work with ECS, you have two different launch types. You have ECS on EC2, you have ECS on Fargate. In the ECS for EC2, you pay for the hardware, basically the VM machines that you spawn up. Whereas if you go with Fargate, you pay for vCPU requested and memory requested. You do not pay for the ideal time. So let me give you an example. Imagine that you have to run 10 containers on one machine, which is say M5.large. What is M5.large? Just for the reference of everybody, it is 2 vCPU and 8 GB of the RAM. You pay for the whole virtual machine, whatever like the cost is that, right? I think it is 0.010 something like that, if I remember correctly. So that is the cost per hour that you would have to pay. Even if your containers use only 2% of the CPU, you will still end up paying the full cost of the virtual machine. Is it clear so far?
Yes.
Now, in case of the Fargate, you take one container with 0.5 vCPU and 1 GB of the RAM running 24 hours. In that case, it would be costing as whatever like that. I think it is 0.9 per day. So if you scale to 100 containers, your cost would grow linearly. So usually from my own experience and from my own learning so far of using the cloud previously for the AWS, we realized that if you have a very unpredictable load, right? If you have very short-lived load, if you have like a cron job running, if you have some kind of application which has to run for 5 minutes and then die, and it would run in like a very short-lived workload manner, then Fargate is the best option. But if you have steady workloads, If you have steady request coming in, your RPS is stable, then of course ECS on EC2 is the right option. Okay.
Got
Good.
it. Why I ask this question, I have a scenario like I have a lakhs of the test cases running in the AWS,
Haji.
and those are not consistent. Once a while, once a week or something, we need to run it. So I think based on your description, I should go for the AWS Fargate. That's more cost optimal than the EC2.
Hmm. Yes. So I hope you get the answer right.
Yes.
Mhm. Okay. Any other question you have?
So are we going to have any live session for all few of these services using our cloud? Lab.
I think that we did cover the AKS part in our last lectures. But
Yes.
if did you guys got the access to the lab by now?
Yes, we got it.
Okay, great. I think yes, you can try that out, and we can be in touch if you get any questions. If you get any doubts, then we can take it up. We are going to cover as and when the need in basis arise.
Okay.
All right, so let's move on, guys. Thank you. Yeah, proceeding on. We saw in the list earlier. I'll just talk about each of the service in a very short bit. Okay, what it is. For example, S3 is a simple storage service from Amazon. This is used to store the objects. Objects in the sense that it could be files, audio, video, pictures, any object. We shall also see later in the class that what is the difference between the block storage and the object storage. Okay, then we have EBS, elastic block storage, which is highly used, and it provides high throughput and can handle the big transaction workloads also. Basically, it is a high performance storage service which is provided. The next one is EFS, elastic file system, which offers a similar kind of service for NFS. It helps in the scaling and shrinking, expanding automatically. Glacier, it is a data archival service, which is a long-term backup service which provides a durability of 11 nines. That kind of durability is being provided by the Glacier. Now moving on to the database storage service. We have RDS storage service from Amazon, which is also called as relational data storage service basically. And it provides a SQL type of storage where I can store and query the data. They are of resizable capacity. They can basically help us in automatic hardware provisioning, settings, backups, and other things also. Okay. So you also have the Amazon Aurora, which provides support for database engines like MySQL, PostgreSQL, compatible databases as such. But the performance of the Aurora MySQL is 5 times more than the performance of the plain MySQL, which is installed on the simple hardware. For Postgres, the performance is, I think, 3 times better than the Aurora version as compared to the simple hardware. Then you have Redshift, which helps in running the analytical queries against the big data. That is the data of the terabytes and the petabytes. It is stored in the Redshift. You can run the query and get the results from there. That is what Redshift helps us with. Okay. I hope that some of these tools are enabled in your big data lab, if I'm not wrong. So I encourage you to try that out and discuss with me if you get any challenges and questions. Now moving on, here we are talking about the networking in the content delivery service. So here we have the VPC, which helps us in creating the logical isolation in which I can launch multiple services. Amazon CloudFront, which acts as a CDN service. Transit Gateway provides a single connectivity between the VPC and the on-premise network. This provides private VPN, basically provides private tunnels, and Direct Connect provides a direct dedicated connection between the private networks and the AWS. Route 53 basically provides a domain name service. Moving on, security, identity, and compliance related services, IAM. It helps us to create roles, groups, users, and policies. You create users, then authenticate them and authorize them so that they can use the services as such, or to building the certain policies to access the resources. These access related things are accessible or possible with the help of infrastructure as a service, with the help of IAM, infrastructure as a service. AWS organization, this service restricts the service which shall be available to the particular user's account within respect to the organization. AWS Cognito, this service helps in single sign-on and access the control mechanisms to the mobile and web applications. AWS Shield, basically it is a protection service against the distributed denial of service attacks. So if you feel that your service can be under the distributed denial of service attacks, then it basically means that you are expecting the huge number of requests coming in from the unidentifiable identities, which basically sucks up the compute resources available. And therefore, the actual and legit accounts clients are not being served. Guys, here we are talking about the distributed denial of service attacks. This means that we are talking about the distributed network of servers connected to each other. Then AWS KMS, it is used to create and manage the keys in the AWS ecosystem. And then AWS Artifact helps us in audits and security compliances as well. All right, so quick question now to all of you guys. I want all of you to answer, please, okay, in the chat window. Please keep yourself ready in the chat window now. So the first and foremost, here we are looking at the sandbox environment, which you would have into your AWS account, okay? So the first question is, under which service category does the IAM service appears? Question 2B1, 2.B.1. Please give your answers in the chat window. Everybody, please participate and write. Very good. Security, Gautam, security basically. Under which category does the next question, does the Amazon VPC service appears? What is your guess? Very nice, Gokunur. Yes, network. That is right. Next, does the subnet you have selected exist at the level of the region or at the level of availability zone? What do you think? Subnet is available at the level of the region or AZ? Quick. So guys, subnet is available at the level of availability zone. Now we're creating a VPC. Does the VPC itself provides a level of region or the level of availability zone? Tell me. VPC. Yes, you're right. VPC is at the regional level and not at the availability zone level. Yes, Pandey. Next question, which services are global instead of the regional? Tell me. EC2, IAM, Lambda, Route 53. Which services are global in nature? I'm again, yes, is definitely global because I can log in from anywhere and everywhere. The application can be launched from anywhere and can try to access some other services. What about EC2? Regional, yes. What about Route 53? Come on, Route 53, no. Route 53 is global. Okay, good. Now let's move on, guys. The model which is provided by the AWS is a shared responsibility model. Now, as depicted in the picture, here are two entities basically, which comes into the picture. The first one is the AWS and the second one is ourselves, the customers. Both of us basically, AWS as well as the us customers, share the responsibility. What kind of responsibility do you share? For example, AWS operates, maintains, and manages various components which are part of the software virtualization layer. All of them below that, you can see you have the compute and the storage resources. AWS manages all of that. It protects the whole infrastructure which is present below the software layer. So the hardware infrastructure which is provided, that would be the compute capabilities or the network capabilities. For the various other capabilities, all of them are abstracted, maintained, and managed by AWS. Okay. So these are all the responsibilities of the AWS, as I covered. Now, what is the customer responsible to? The customer is responsible for the data. When I say data, basically it means if you want to keep the data safe, then the encryption is something that the customers would have to do. If the data has to be kept secret and safe during the transit, then the customers would have to take care of it using the SSL, TLS. Okay, that's not something being done by the AWS. What kind of the network needs to be configured for the security? AWS provides the services, but it is you who has to choose the availability zone or the region. Of course, you cannot select the data center. Apart from the security credentials, the login details of the user, the creation of the groups, what kind of permission do they have to all the services do they have access to? All those things comes under the responsibility of the customer. Customer is also responsible for creating the virtual machine, choosing the operating system, patching the operating system, provide the update to those operating systems which are there in the virtual machine, providing security group to that machine, making sure that the virtual machine itself is providing security group to, so all of this is basically the customer responsibility. So in short, to make sure that the virtual machine is secure enough, the customer is responsible for all of these things that I just explained. So guys, here are some examples of the infrastructure as a service, platform as a service, and software as a service. In infrastructure as a service, we have EC2, block storage, and VPC. In platform as a service, we have Lambda. Please note here that we do not have the infrastructure here. We have a code which we want to run. We pay for the time for which this particular code is running. Then relational database is also managed service as such. Here we are not looking into other aspects such as what kind of servers are there, what is that you have installed, nothing else of that sort. Likewise, even the beanstalk here, what happens is that customer basically focuses upon looking into the code, managing the code, maintaining the code and the data. Similarly, there are offerings from the AWS SaaS also. As I said earlier, the leader in the SaaS when it comes to the cloud market is the Google. When it comes to AWS, they have Chime. Basically, they have Chime, where they started, I think, half a decade ago. Then they have AWS Shield. I have already told you what is Shield is. Basically, it is a protection service against the distributed denial of service attacks. Then we have AWS Trusted Advisor. These are all the SaaS examples when it comes to Amazon. Now we shall move on to the service which is a part of the security, IAM. This shall talk about the IAM, what IAM provides to us. It provides identity and authorization policy. It helps us to create the users as well as helps us to set up the authentication for them, as well as authorize them with respect to the policy specifying as to what are their policy access roles. Okay, which user can access what service, which user can manage, create and edit the instances. All these things are basically controlled and provided by the IAM. Okay, so if I have an S3 bucket and if I have an EC2 instance, now if this EC2 instance have to access the S3 bucket, say for example, in order to access some images or store the data, then I should have a policy attached to the EC2 instance saying that it has access permissions to the S3. There I can again define whether it is read-only access or the full rights. I can access those details as well, which helps us with the user access control. So we can define very fine-grained access rights as such, that is who can access the resource, which resource can be accessible, what is that they can do with these resources, and how are these resources accessed. Whether these are accessible through the application or through the CLI or through management console, etc. All those things are defined over here. Basically, this is a free service from the AWS. Okay. So there are four main essential components of the IAM, my dear students, which defines various aspects of the IAM. Like I can create a user, I can create a group, I can attach this user as a part of the group. For example, if I'm creating a DevOps group or network operation group or network administrator group, I can define the various IAM policies which are there. IAM policies are nothing but these are the documents which defines as in how the resources can be accessed or what level of access is allowed for each resource. Okay. I can create these particular policies and enable the policies for the group of particular group. We would be forced with all the policies that we have defined. Okay. Likewise, I can also create the IAM roles. IAM roles are basically a role which grants temporary access to the specific AWS resources. That's what it does. That is a set of the permissions to access these resources. So guys, how do I authenticate the user if I has to gain access to the certain resources? Authentication in the simple terms is what the user provides, where the user provides his or her own identity. How do he prove out his identity? Basically, if we go to the airport, what is that they ask for? They ask for the ticket that we have, and they also ask for the identity card. Actually speaking, the ID card that they see, they do not run it through any system, whether it is a fake ID card or not. What they do is they're just seeing it manually. But I think they're also implementing the facial recognition as well at some of the airports. So basically, I prove my identity before getting the inside into the airport. Similarly, here also, either application or the user, they have to prove their identity before they provide their access. So there are two types of accesses which are provided to the IAM users. One is a programmatic access, another one is the access to the management console. So you restrict and access saying that this particular user would only get the programmatic access, or he would only get the console-based access, or they can get both of it. So if it is programmatic access, I can be writing some scripts to use the access key ID as well as the secret key access. Using this particular information, I can get access to various resources. Okay, this is the part of the CLI as well as the SDK. If it is through the management console, that we can authenticate using the 12-digit account ID. Of course, you don't have to remember the account ID, but you have to remember the user ID and the password. Of course, you can also enable the multi-factor authentication. That is also possible, which can be prompted at the time of authentication as and when it is required for any user. Okay, that's all about the user identification. Now, yes, the user has been identified. Now, going further, I have to authorize him also. Authorize for what? Basically, to tell what a user can do with respect to the various services. After the user or the application is authenticated with respect to the various with respect to their AWS account. What is that they are allowed to do is they are is provided by the authorization. As a group or user or the role, by enforcing the policies, I can make them access various services. So there can be IAM policy which says the so and so user have full access to EC2 instances, whereas I can define a S3 bucket resource which would only have the read-only policy for everybody. Everyone means it could be user, group, or role. Everyone would get the read-only policy. Okay. Using the IAM policy, you can even deny the access. You can define a separate section specifying the denial of access as well, basically. So guys, the IAM authorization follows the principle of the least privilege. What is the meaning of the least privilege? You provide access control to only so much so that it is whatever is required for that user or the group. Nothing more than that is, provided. Generally, what do I have as a root user? I have access for everything. Okay, but that is not the case with all the users. Then what is then when the user is created, everything is explicitly denied. Nothing is allowed. Then they enable the particular service and says that this particular user can do so and so much with respect to so and so services. Okay, so we start with absolute denial and then move into the applying access permissions. So this IAM, whether this is global or local, we saw that earlier itself. Scope of IAM is global. Whatever settings are applied across all the regions as such. Why is that so? Because access can happen from any part of the world to any region as such. To any region it can come. But all the policies, all the authentication and authorization should get enforced. Okay. Next is IAM policies, my dear students. Policy basically define as to what traffic should be blocked to the resource from an incoming IP or incoming subnet, to what level I can go and create a policy. The policies are of two types: identity-based policy and resource-based policy. Resource-based policy, what it says is that, say for example, you have S3 resource, I shall create a policy for that stating that this particular bucket would have only read-only access. Okay, so I create a policy. Later I create a EC2 machine, and now this EC2 machine have the access to the S3. Okay, so when I create this particular EC2 machine, there is a role which is mentioned. There I can access this particular role, which would have a policy which states that I can only access S3 for the read-only purpose. That's basically a resource-based policy. Another one is identity-based policy, where I attach the policy with any of the IAM entities like IAM user, group, or the role. What do these policies specify? They specify what the user can perform or what is that the user cannot perform. They specify what is the user can perform, what the user cannot perform. Both of these things are there. That is, accept is also there and deny is also there. So guys, this is the examples. If you see in the above part of the screen, it is allow, and the below part of the screen is deny. And here are some actions which are mentioned over here. Here it is explicitly allow, which gives access to specific DynamoDB table and S3 as well. This is the S3 bucket. Okay, and in the below part of the screen, there is explicit deny, as you can see, which means that user cannot access this particular resources, this particular DynamoDB resources or S3 bucket other than the above mentioned resources. Anything apart from the above mentioned one says that it cannot access them. Okay. Explicit deny takes precedence over the allow. Please note, this is very important concept. I repeat, explicit deny takes precedence over the allow rules. So one example. So we'll first check, is the permission explicitly denied? If there is a yes, then there is absolute deny. If there is no, then check if the permission is explicitly allowed. If there is yes, then allow. If there is no, then there is implicit deny the access. We already discussed the resource-based policy, my dear students. What we are trying to do over here is, once again, I'll tell you, these are the users which are created, which are attached to the particular policy. Policy specifically grants the access. I mean, this is the resource-based policy attached to that. It is inline, because of which I'm creating an S3 bucket, and I can specifically select this policy and say that this is what it will apply to this particular bucket. That's the reason it is called as inline, whereas in the left portion of the image it is attached, and in the right side of the portion of the image it is created inline. Okay. Next one is IAM groups. They are nothing but the collection of the IAM users. Whatever is applicable for a group, it is applicable for all the users which are part of this particular group. And there is no default group. These groups can not be nested. Guys, then this is the IAM role. As I told you, IAM role provide temporary access permission to the specific set of resources. So it is different from an IAM user in a sense that it is not associated with a single person as such. It can be used by a person, application, or a service. Whenever we create certain things for EC2 and all, what we create is a role. What we select is role for these different services which shall need to be authenticated. As an example, you can see IAM roles are used to delegate the access. This can be used by an IAM user in the same AWS account as a role. This can be used by an IaaS AWS service such as EC2 is the same AWS account as the role. This can also be used by an IAM user in a different AWS account as the role also. Okay. So here is an example. We are creating an S3 bucket and we create an EC2 which needs access to this S3. What we need to do is we define the IAM policy, and this policy would help to grant the access to the S3 bucket. Okay, so attach the policy to the role. When we create the role, allow the EC2 instance to assume the role. So this is what it happens. This is not resource based. Okay, this is for IAM entity. Fine. So I hope you guys understood. This is what that I had to cover. Now, if you have any questions, any doubts, please ask me. All right, guys, moving on very quickly. I'll take now I'm going to assign the announce the assignment. Guys, the assignment consists of the 3 parts. Please hear it very, very importantly. There's a test bed. The first part is a test bed presentation. You need to present a test case study, a test bed that basically how a cloud migration helped in a specific use case. You can pick up your own specific use case from your own organization or from some heavy industry assembly unit or some kind of IoT environment or some data science related or whatever, healthcare, whatever. So you would come up with a use case, present the purpose of using the cloud, and how did it solve the problem. A lot of test beds are available on the internet. You can pick any of them and do the presentation. You don't have to build it. You don't have to develop it. You just have to present that particular test bed. With this, the objective is you should get a lot of use case to understand, and we basically will form around 20-25 groups. Okay. Now, next is something very important. This is like something the hands-on part. You have to make your hands dirty, develop a small application or proof of concept using the various tools available in the any cloud, whether AWS or Azure. So something innovative should come out of this particular activity. You need to develop basically leveraging the cloud. You need to come up with an idea which you plan to implement. That's the second part, and discuss with me. The objective here is to basically whatever the knowledge that you have gained over the period of the time so far, we want that knowledge to be put in use to get the concrete projects created. Basically, I want your knowledge of the subject becomes concrete by your hands-on experience. The third and the last one is a detailed report that you have to submit the test bed presentation along with the detailed report. And it shall be group assignment. The group assignment would be done by me. Maybe you can come up with your own groups. I will just lock that one. 25 marks for each student in a stake here. So don't take it lightly. This is a very, very major component. Maximum group size is of 5 members. So please feel free to form up your own groups. Okay. Final assessment of the evaluation would be in the form of a presentation where all the 5 members would have to submit this particular final report, the presentation, final report, and the working prototype in an email or in maybe any format. Okay. That's what about the assignment, guys. I hope that I'm clear with all the details of the assignments. I will also announce it on your Taxila platform. If
Sir,
anybody have,
this detailed report comprises of the test bed presentation and also what is the activity or kind of small work that we perform, right? Both.
the
Is it?
detailed report is about the second part, which is your hands-on demo, hands-on thing
Okay.
that you.
Okay. So, and apart from that, sir, I still am not having the access for the labs. I have just seen.
Email. Send an email, please.
Yeah, I already sent, sir.
Maybe again, please today,
Okay,
because
sir.
there was an issue earlier. No?
Yeah, sir. Okay.
Yeah. Yash Pandey, the first point is basically you pick up your own test case study. Like test case means, like for example, pick up any company who has moved to the cloud, who has performed migration to the cloud, and what are the benefits that they obtained. Or you can have your own use case from your own company, or you can pick it up anything from the internet. Okay. Ravi Kumar, can you share some few use cases? Ravi, you should come up with your own. The idea is basically to let you people innovate about it. Okay. Okay. Somebody please add Ravi, Yash, etc. with the WhatsApp group, guys. So as the next step of action, please come up with your own group numbers. Okay. That is very important, guys.
The activity topic also we need to select our own, right?
Yes.
Okay, sir. And any cloud, I mean, either Azure or AWS, both are
Or Google,
equivalent, right?
or Google,
Okay.
or Alibaba,
Okay. Okay.
or Oracle, whatever, OCI, etc. Whoever is not able to access the lab, please send me an email, fresh email right now, and I will escalate it along with the problem that you're getting, along with the error that you're getting. Okay.
Sir, for me, it's not even appearing in the drop down, the subject itself.
Yeah, whatever. Like, please do me email.
Okay, sir. Thank you.
Guys, please pass on this information and kindly share with me an Excel sheet by talking in amongst yourselves that, hey, what is that, your groups that you're forming. Thank you. And we'll meet in the next lecture. Take care. Bye-bye.
Thank you, sir. Thanks, everyone.
Thank you, sir.
Thank you.
Bye.